Hello, it is Friday, December 16th, 2011 at 8:09 p.m. Central Standard Time. And last week I was doing quite a few videos on the snake clouds that were rising out of the Gulf. And a gentleman named Bill Hayes sent me a link to an article, and this is what he said. I make mention of this due to the fact of the project now ongoing in the Gulf and the barges with massive electronic equipment deployed there during the last 4 months. I believe there are more than just snakes amidst the ranks of clouds. These new radars are very high-powered, narrow-beamed, and high-frequency units that have extreme backscatter that are dangerous to man and animal. Please note that the article mentions that they are unmanned units. Note also that it mentions aerosol research. And this is the article that he sent me. It was physorg.com. But from what he sent me, it led me to ARM's website, which has the exact same article, and I'd like to read it to you. It's dated December 8th, 2011, the world's largest radar laboratory. New suite of scanning radars document life and death of clouds. San Francisco. In the past year, the Department of Energy's Atmospheric Radiation Measurement, ARM, Climate Research Facility deployed 18 new scanning radars at its research sites in Oklahoma, Alaska, and the tropical Western Pacific. These highly sophisticated new radars are providing extraordinary four-dimensional information to help scientists better understand the life cycle of clouds. Today at the American Geophysical Union meeting in San Francisco, Gerald J. Mace, professor of atmospheric science at the University of Utah, discusses the research implications of these radars during a press conference on new weather and climate technology. Throughout the week, numerous other researchers presented preliminary results using data collected from the new radars. These new radars provide the world's most detailed data about the formation, structure, and evolution of clouds and precipitation. These details are very important for accurately simulating cloud processes in climate models, particularly for underrepresented regions like the Arctic and the tropic Pacific. Like the Doppler weather radars that TV meteorologists use for daily weather forecasts, the precipitation radars can measure the size and shape of water droplets and ice crystals falling from clouds, as well as the speed at which the cloud system is moving. The new cloud radars, on the other hand, emit pulses at much higher frequencies, improving their sensitivity to microscopic cloud particles. And unlike other cloud radar systems, they also operate continuously and unattended to provide data over time, the fourth dimension. Combined, the data from both types of radars give incredibly detailed information about the interactions between clouds, aerosols, and precipitation in the atmosphere that make up the life cycles of clouds. This complex and dynamic process is one reason that climate models have such a difficult time simulating Earth's climate, both at regional and global scales. Continuous data for climate research. Despite improvements in computing power, current weather and climate models are unable to accurately reproduce the formation, growth, and decay of clouds and precipitation associated with cloud systems. Not only is this due to lack of data about precipitation, but also about the three-dimensional environment of surrounding clouds, winds, and moisture, and how that affects the transfer of energy between the sun and earth. To obtain this type of holistic data, the new scanning radars operate at multiple frequencies. The precipitation radars at 5 and 10 GHz, and the cloud radars at 10, 35, and 94 GHz. At these very high frequencies, the radars can detect particles ranging from 10 centimeters down to 10 micrometers. Various combinations of these radars are now deployed at the ARM facility's 4 permanent sites within 3 of the Earth's major climate regimes: Arctic high latitude at Barrow, Alaska, continental mid-latitude at Lamont, Oklahoma, tropical latitude at Darwin, Australia, and Manus Island, Papua New Guinea. They have also been added to each of ARM's 2 mobile facilities. These portable observatories are deployed around the world for field campaigns lasting 6 months to a year on average to obtain additional data from underexplored climate regions. The new radars, purchased with a $30 million investment from the American Recovery and Reinvestment Act of 2009, were designed and built by ProSensing Inc. of Amherst, Massachusetts, Advanced Radar Corporation of Boulder, Colorado, and RadTech Engineering Inc. from Broomfield, Colorado. They complement the ARM facility's new 35 gigahertz vertical pointing profiling cloud radars and nearly 24 other instrument systems at each site that obtain continuous data to support studies of Earth systems. And this talks about ARM. The ARM Climate Research Facility is a U.S. DOE Office of Science user facility with heavily instrumented fixed research sites in Oklahoma, Alaska, and the tropical Western Pacific. It also operates mobile and aerial measurement platforms to support research around the world. Researchers can propose to conduct their own field studies using these capabilities, and all ARM data are freely available. And then it gives you various links here. We've got YouTube videos, Flickr images, and then also they have been very kind. Let's see, I got to go back one more. And have provided a way to go look at the different places. There's a little map here, and you can pick your site up here, like North Slope, Alaska. Well, is it going to go? There it goes. It talks about like 32 different instruments. And then it gives you the coordinates so you can go and look at it on Google Earth. And then there's also, like here's a picture here, and there's also pictures. Quite a bit of information. Anyway, I wanted to bring that forth, and I do wish that they would make this all more public. I mean, it's available to the public, but for some reason it does not seem to be highly advertised. So God bless you and have a good evening.